Okay.
Oh, Ed, I had one. I've had people ask if I had to give an estimate of how long do I think it might last. How long might we expect it to go?
It's complete speculation. As you know, there's some large potential purchasers in the wing. I know you have conversations queued up yourself, and I think what will happen as we get a few of these larger purchasers landed, that will have an acceleration effect. And people will hear about it. We didn't do a lot of marketing and advertisement and outreach before this. Let's contrast this with EOS token sale, for example, which was a ton of marketing up front, and a huge blitz. We just chose not to do that.
Well, in particular, I mean, I really want to emphasize that this is a private sale. This is not an ICO.
Right.
We're doing this on behalf of all the members who've been approaching me for the last 4 months saying, can I please buy rock? Can I please buy rock? And first I said, well, organize yourselves and come forward with a proposal to the board. And the community wasn't quite at the point where they could do that. And so we took it on to handle all the details, all the legal stuff, all the compliance stuff, and the regulatory stuff ourselves. And basically this really is in service of the community. It wasn't about a big ICO. It wasn't about marketing. It was literally just responding to all the people who have said, please, I want to buy rocks from the co-op. So that's why it's the shape that it is.
Yes, great points. Yeah, so going well, and Greg uploaded a summary of as of, I think it was Saturday night or Sunday morning, and here I will continue posting that kind of summary where you can see all of the pay into addresses and all of the rock addresses that are going out in those transactions, so you can verify on the blockchain. Great. Other questions?
Yeah, in terms of the private sale, there's one detail I wanted to point out, which is when you register and you go through the process, at the end of it, there's a very nice component where you can pick time slots where the interview could happen. And I'm through that, and I looked at my calendar and I filled out the number of time slots. And then a couple of days later, an email arrived, and the question was, when do you have time to do the interview? And I saw this happen with an email from Evan as well. And so it seems like that data is not being used, and it's a little bit of a unexpected twist in the process.
Yeah.
Thank you, Kit. Part of the reason why we're doing that is because it's taken so much longer to get through the interviews than we had hoped, that in many cases, what happened was we were sending out the interview to confirm, or sending out the email to confirm the interview after the time when people had supplied that. So you can simply see the question as a confirmation. If the times have not yet passed, you can see it as a confirmation of the times, and if you provided an option, then we still need to know which of those options is the best one for you.
Yeah, but good point, Kit. I'll admit some guilt that I don't always look at those times, but just because of my schedule, and try to line up. But yeah, many of those passed the first couple of days, but the ones still coming in, it's a good reminder to look at those time slots. And we're still getting memberships coming in. Maybe in a moment I can look at the number of overall memberships that are coming in, but they're coming in over the last 4 or 5 days at a clip of about 3 to 5 per day, and then some subset of those are interested in purchasing rocks. So now a lot of fun will begin in terms of membership governance. Now that we have official membership list, and so now questions are coming up. Okay, how will we actually conduct votes and and so forth, and so if also if anyone has gone through the membership process here and are not seeing some of the private channels that or member only channels that are on Discord. For example, there's a private sale address channel is one of the several. If you're not seeing a number of channels like that on Discord, let us know, because then we can check your member ID, some information from your membership process with your Discord ID, and then one of us can flip the bit to indicate you're a member. And some of these processes are still a little bit manual, and we'll work them out over time.
Yeah, absolutely. And also, I should mention that the developers have moved over from Slack to Discord. And so if you want to be able to talk with the developers, you need to move over to Discord, which means you need to be a member. So that's but what we're trying to do now is to shift our conversation from the Slack channels, which are largely going to be focused on the public facing part of Rchain. So those who are not the members can approach Rchain through the Slack channel, and the membership and all of the communication with respect to the membership is now going to move over to the Discord channel. And most of the leadership is going to be engaged at the on the Discord channel with the membership beginning from now. So that's and that helps kind of raise the bar, the quality bar on the conversations. I think Slack has been, as we've all seen, Slack has suffered a little bit because the conversations are not always of the highest quality, because just about anyone can join. And hopefully with the Discord and the ability to manage those conversations a little more closely, with attention just to the quality of the interactions, we'll be able to have a higher bandwidth conversation with the membership. So any questions about that? Any questions about our intention with respect to communication? All right, I guess that was super clear. Okay, so I guess we can move over to some of the questions. Actually, I thought that was a really nice question that came up with respect to mapping the core computational abstractions onto the user experience. I was delighted to see that conversation, and that took place on the proof of stake channel over in Discord. Ed, did you want to repeat the question? Because I think this was probably interesting and useful to a lot of people.
Oh, well, you now I'm trying to remember. Oh, yeah. Okay, you were talking about user experience, but yeah, now I remember it. So yeah, for those who want to look at the details, just go into Discord proof of stake channel. So this originally came from one of the rock purchasers when I was trying to describe namespaces and how namespaces enable Rchain to scale. And I realized that my understanding wasn't as crisp as I was comfortable with explaining it. I could only get so far in my explanation. Then I said, "Oh, well, you'll have to talk to Greg for the details." And then I realized I need to know that answer myself. So the scenario is, for example, Alice is interacting, sending revs, say, to Bob, and Alice is also sending revs to Carol. And so those should both be smooth transactions. Now, let's say Bob is, a large high transaction merchant in Seattle, and Carol is really a large transaction merchant in Berlin, say. And normally Bob and Carol don't interact. So my question was how that maps onto namespaces. What are namespaces really? And what do nodes have to care about? So if let's say I'm Alice, I have a wallet or other node that cares about what's in my balances, and I'm Bob and I'm Carol, um, and don't want those nodes to be configured that they have to care about all transactions of Bob or all transactions of Carol. So how does that work? That's sort of the setup. And Greg, I guess I'd like you to take it from there. What's the answer of compositional namespaces and nodes?
Right. No, this is all really good stuff, and I posted the answer in Discord, so I'm just gonna talk it through here. But if you want to see the textual answer, it's also in the proof of stake discussion, the text channel over in Discord. So the first thing to understand is that our abstraction is built around the notion of channels. And so everything, including everything in the sort of address space of blockchains, will be considered a channel, and that's a natural intuition, right? You can think of communication happening between two agents through either Bitcoin addresses or Ethereum addresses, right? That's sort of a very natural intuition, and so it lines up very well with our notion of channel. But our notion of channel is a little bit richer, and it can handle other things besides blockchain addresses. And actually, Tim raised an interesting question in relationship to this and the virtual machine, which we'll get to in the developer stand-up later today. So once we see that our abstraction is a little bit larger than addresses, then the next thing that we want to understand is that users and contracts interact with each other through channels. And now we have to recognize what the relationship is between users, contracts, and names or channels and nodes. So effectively, two users or two users and some contracts will engage with each other through a set of channels, and those channels occupy namespaces. So what is a namespace? And this is the kind of the critical or the crucial understanding. A namespace, at least at the core of it, is just a set of channels. That's it. It's just a set of names, nothing else. Now, the interesting thing is that when we talk about collections of names, there are two ways you can identify or specify a collection. One is to give it extensionally. So, you just list out all of the elements that are in the collection. So, for example, one collection could be Bob, Alice, and Carol, or the addresses associated with those users. That's a collection, and I gave it by telling you exactly which members are in the collection. Now, another possibility is you give a rule or a program. And what that program does is to, sorry, I'm turning on my coffee machine because I haven't had my coffee yet this morning. So if there's a little bit of noise, my apologies. So when you have a rule, the rule describes one of two things. Either it expands out to generate the list of or the collection of elements, or it recognizes when an element is in the collection or out of the collection. So that is a programmatic description, and that's where namespaces start to get interesting. If you had to list out everything, then that would be kind of boring, tedious, and not very performant. But when you have rules that allow you to calculate what's in and what's out, or to generate a list of or a collection of what's in and what's out, that's when it becomes much more interesting. We use this to great effect in lots of different aspects of the Rchain architecture. But in this case, if you look at Mike Stay's response to Ed's question as well, he gives some simple rules for calculating the combined or composite namespaces for Bob, Alice, and Carol. the important point then is how to relate the transactions across the channels to the namespaces and to the nodes. So the first thing to understand is that a node can serve multiple different namespaces. And how does it serve those namespaces? So what a namespace provides, or transactions is probably the best way to go in through this. A namespace, a transaction occurs when there's an I/O event across across a channel. So, for example, Alice wants to give some rev to Bob, and Bob wants to receive some rev from Alice. So that's what a transaction is, and transactions occur. Since transactions occur at channels, they occur inside namespaces. So that's the critical thing. And now, what makes a transaction possible is that there are a set of validators, or a collection of validators, that are all agreeing that the transaction occurs. So namespaces are served by nodes, which are agreeing, and what they really agree on is the winners of every race. So if you have two transactions sort of vying for the same resources, only one of them is going to win. And what the validators agree on is who the winner is. So this allows you to have both concurrency and a kind of determinism at the same time. So if there are a pool of validators that provide for the composite namespace, in other words, the one that involves Alice and Bob and Carol, then you are guaranteed that the transactions can happen and that everyone agrees on exactly which transaction happens. If there are no validators serving the composite namespace, the transactions can't happen. And so you can't get your double spend. So that's the argument in a nutshell. So that's a lot of concepts, a lot of ideas. So let me stop there and see if there are any questions or any comments about how all this fits together.
So, Greg, this is extremely helpful for me, and I appreciate it. So let's just take Alice and Bob. You were saying, so there needs to be a validator that will validate those transactions, and then so what's sort of the critical mass of the number of validators that need to validate that transaction, and especially if there were a double spend before it might be eventually final, if you know what I mean.
Yeah, sure. So again, I think what we really want to do is we want to associate trust with sort of validators and stake. I don't think that we necessarily want to say that there's a specific number. What we want to do is, so if there are some intrepid users of a particular namespace who are fine with a pool of validators, say, at 5, with a stake of rev at, I don't know, 1 million rev per validator. Maybe there's some people who are perfectly fine with that setup, and so they are willing to conduct transactions in that namespace, and so that's really going to be a matter of confidence with respect to the namespace. I don't think that we want to fix that. That's not a policy. That's really on the user itself. So some or herself. Some users will require a richer set of validators, and other users will require or are happy with a smaller number of validators. We think that this is really important when we talk about staging of protocol features. So for example, you might have a test namespace that's staging out some protocol feature that only has a handful of validators, and people are taking a look at this from the point of view of trying it out in the wild while not really relying on it too much. So this is why the namespace approach goes hand in glove with the practice that we're actually seeing in the blockchain itself, right? There is such a thing as testnet and mainnet, and both of those are namespaces, right? Both of those are really different namespaces for blockchains that are related to each other, but the relationship has not been formalized. Here, the namespaces actually formalize those relationships. Does that help answer the question?
The way I would look at it is that if there's a transaction with me and Bob and Alice, I say, if I get 5 validators, I'm fine. So 5 is all that we need. Alice may want 3, or Bob may only need 1. I think what the contract is that I was validated, that I consider the transaction to be validated.
So that's an important question, Jim, and thank you for putting a finer point on this. So again, the real point is whether in the current design, all of the validators that are in the namespace all have to agree, right? So Alice may receive confirmations from 1 or 2, but at the end of the day, the transaction isn't finalized until we reach the finality threshold for that validator group. But that's separate from whether or not someone wants to participate in a namespace that only has a handful of validators, right? It might be the case that they say, no, I just don't trust that validator set for this kind of transaction, right? And that is what enables people to kind of engage with the level of confidence that is necessary for them for the kinds of transactions they want to commit. So what I'm trying to do is to separate out the notion of finality from when you engage in commerce at all.
Great. I have a question about so when you say the collection of channels is defined by a rule, I assume, since you didn't say this specifically, that rule can be defined by, I would say it probably should be defined by a validator, because then you have validators with rules to create a namespace. But if the rule was created outside of a validator, you could still have a channel, but there would be no way to verify any transactions. Is that correct?
That's correct. That's exactly right. Actually, the mechanism for defining namespaces is part of the Rchain spec, right? That's it grows from the namespace logic, where there's a correspondence between names and row-lang programs, right? more accurately, row calculus processes, but for this community, row-lang programs is a reasonable proxy. So names in the purest form of the architecture are just quoted processes. Now, it turns out that you can do quite a bit more once you have that basic mechanism as your bootstrap, as your ground. Then you can add in other kinds of names. For example, Ethereum addresses or Bitcoin addresses or URIs. Those are examples of valid namespaces, and that's a part of the Rchain spec. And you'll get more and more and more specificity on this as we get closer and closer to Mercury.
And this would also, to tag onto that, this would also how you could integrate other communication between other chains with Rchain because of namespace.
Exactly right. That is precisely it. Yes.
Hey, Greg, this is Danny. One quick question. So, if we roll the tape back just a little bit there, where you were talking about Alice and Bob and their namespaces, or the namespace that didn't exist in order to facilitate a transaction between the two of them. The only part that I maybe missed in there was what the mechanics are for getting to a namespace so that we can have a transaction. So I'm also looking at Discord, and I see that in a response to Ed, you're saying if there are no nodes that handle transactions that combine the namespaces, then the transaction cannot happen.
That's correct.
And I understand that. So let's say we're in a situation where Alice and Bob fit that condition. There's no node that handles transactions that combine those namespaces. So what is what needs to happen in order for Alice to transact with Bob?
Right. So that's a great question, and the real answer, the substantive answer, is actually economic. If there are lots of Alices and Bobs that want to conduct transactions across such a namespace, then there's a significant economic incentive for validators to serve those namespaces, and so they will fill the gap.
I see.
Yeah.
I see. So Alice, so if Alice wants. Oh, go ahead, Jim.
Sorry. From a user perspective, you just add a reference from one namespace into another, and you have a namespace. I mean, getting a namespace isn't a problem.
That's correct.
Okay.
So you can, from any contract, you can calculate the namespace that it's going to transact over, and we can do that syntactically. Okay.
Okay.
You can generate the program, which will generate the names.
Gotcha. Okay.
Right?
That's
what
I wanted to
It may be an infinite set, right? But you can generate a program which will generate the names that the contract interacts over. And now if you have lots of instances of that contract, or lots of contract instances that sort of cover that namespace, then there's a significant economic opportunity for validators that want to serve that namespace. Are we all good?
Let me ask one more question about this intentional versus extensional.
Yes.
I'm not even sure how to form the question. Let's call it a query of whether a transaction is in a namespace or not. So let's say I'm a node considering to do a validation. Then I would have some filter on over which transactions I want to participate in or not. Let's say if it's a participation in the content delivery 1 gigabyte transaction namespace, I don't want to deal with those. So how would I filter in and out which transactions I care about as a node?
Right. So the way you filter that out is because you're going to assign to a particular channel particular capacities. And then you can determine from the channels that are mentioned in the contract that is being proposed that you run, what the node capacities are, or what the channel capacities are. Sorry, not node capacities, what the channel capacities are. And if those match your requirements, then you can admit them. If they don't match your requirements, then you don't. And this is, again, in large measure, it touches very closely on the cost spec that Joe Denman is working on. So where we have a very, very clear notion of the idea of channel capacities. So channels are declared. The type of messages that go across these channels are well spec'd, and the corresponding load and cost requirements are associated with those declarations. Does that help?
It does. I'll have to read up on that because before this explanation, I didn't think that what a node cared about and the cost were related to each other. So that's cool.
Yeah. Well, they have to be. They actually have to be, right? Because if you know, if a communication requires a certain bandwidth, right, then the node is going to be involved in that.
Exactly. So I just didn't know if that was all declared up front or it's more figured out as things are coming by. So
yeah, no, but see, that's the nice thing is that the contract declares it, and then the node can use the declarations to say yay or nay.
Yeah, and this is partially of this definition of extension with an SION.
Yeah, right.
Yeah, okay. That's a relatively new concept for me. So I'm, I will admit this old, probably 20, 30-year-old definition in my head about what a namespace was that it was a declaration ahead of time, like HTTP foo.com, and things that lived under there lived in the foo.com namespace. And of course, this more general concept of namespace is much broader than that. So I'm having to undo that previous wiring, if you will, that name. That
Now,
term.
notice that you can still declare it up front, but not have, but be lazy about knowing what the actual elements are.
Yes, got it.
Here's an example. P of n is equal to 1 plus P of n, right? So and 0 and P of 0 is equal to 0. So now I have this this lazy specification of the natural numbers. And that's so, you know, I've declared it up front. I told you the rules, right? But I didn't give you all the natural numbers because otherwise, you know, we wouldn't be ever done with this call. So we get in many ways we get to have our cake and eat it too.
That's cool.
Yeah.
A new name just appeared on. Oh, a couple new names actually. I wanted to welcome Griff, who's I think new to this hangout, and Giotto. Welcome.
I think Griff has been on here before, right? He's given some demos, and we actually have a demo scheduled for today, if I remember correctly. Is Chris on today?
Oh, I'm sorry. There's two Griffs. Got it.
Yeah, Chris is on today, and he's last week he said he'd give us a demo. I don't know if he.
Yes, I'm here. Sorry, can you hear me?
I can hear you. Yeah.
Good. Microphone works.
And also, I want to say hi to Giotto. So what brings you to block space, Rchain land?
Hello. Can you hear me?
Yes.
Okay. I don't know. I mean, a friend of mine told me about this project. So he's like some expert in cloud computing, and for some reason he had reviewed it, and he told me it was very good.
Cool. Well, it's nice. It's nice to have you here. It's always good to meet a new face, and feel free to you know, ask any questions that you might have.
So this is mostly a technical chat, I guess.
No. We actually talk about all aspects of the project.
Okay, so you like the people here are like investors. They are like the developers. They are like the team.
Everybody. So we have developers, you know, visionaries, investors, participants, and many stakeholders of the entire community are represented here.
I see. So what do you see as an example of a very an important use case? Let's say just like Ethereum use case became the ICO. What do you see as the potential use case for this?
Yeah, so we've talked a lot about various use cases over many years, but one of the most important ones is we view that social media, as an example, is a very important coordination technology. So think about, I don't know if you use Facebook or Twitter or Instagram.
Yeah, not much, but I do it. Yeah.
Yeah. Okay. Great. So if you know, picture in your mind your Facebook feed, and now think of every single post being a smart contract.
Mm-hmm.
Right. Now, Ethereum just simply can't handle that scale.
Of course.
Right, and it's not even not even on their roadmap to handle scale like that.
Yeah,
so, yeah. Right, but that is the kind of scale that we can handle.
But how is that possible? Because even from a storage point of view, I mean, would it make sense to store?
Yeah, so we've been talking a lot about that. Actually, just in the last little bit, we were talking about namespaces, and
I know, but still, so it requires to store all this data. So
no, yeah, there's plenty of capacity out there in the network to handle all kinds of storage like that. There's actually that's been well documented that the data centers are actually not a requirement. They're good, and there's no reason not to have them in the mix, but they're not a requirement for a large number of applications that are data rich. And
right.
This is an example of one.
And we earn rev for providing storage. So
yeah, exactly. There's actually an economic incentive for people to provide storage and to participate in.
But so in that case, let's say this sort of decentralized Facebook. So how will it be financed? Because in the normal Facebook, there are the ads, and that's a centralized concept. Now, in this case, someone has to pay for the storage, and there are no ads, I guess.
So one of the things that provides a good financing model is a model around the promotion of content. So you can imagine a currency that someone defines that makes it possible to promote content by using that currency to promote content. And now
Then
there
who
is
will define the rules? Because I mean, in that case, so let's say because the way I imagine it would be, so let's say people find some way to organize that data, but that doesn't necessarily has to be represented in some form of user interface. So it's like you cannot really, I mean, on one hand you have the data, and on another hand you will have the user interface. So you cannot necessarily impose a specific user interface, meaning that you cannot necessarily impose the ads or the.
Oh, I mean, so now you're talking about that there needs to be an agreement between the contract that represents a post and any user.
No, because what I'm trying to understand is it's this. I understand it is decentralized. So if we look, let's say, like step by step. So there is a decentralized model which will store, let's say, posts and like images. So people can store those on some decentralized network, and let's say they can refer to them with some, let's say, some hash. But then they may not necessarily be a consensus about how to organize the data. So do I want to see only from my friends, also from companies, in which order I want to see the data, and then do I want to see ads in the mix or not? So there may very well not be a single consensus on that. So everyone may just see that data differently. And so, and because there is no, in Facebook, you can actually impose all the data is consumed, which means it's a valuable platform for ads. In this case, you cannot really impose how the data is consumed. It looks like more like the internet, that anyone can just put some URL somewhere and anyone can just type a URL and see that URL. But
okay, so let me make sure that I've understood your question. Is your question about the relationship between the smart contract that represents a post and how someone views that contract?
For example, but I'm not even sure why it should be a smart contract. I mean, potentially it could be just small bits of data.
Right.
So
the reason to make it a smart contract is precisely so you can support the promotion economy, right? So there needs to be, right. That's why. So each contract each post has a wallet associated with it, effectively, which is how much it's been promoted versus how many people have seen it, right? So when someone clicks on the post or engages the post in some way, then that ought to result in some of this promotional currency being deployed. And when someone promotes it, then that sort of adds to the post's wallet in a certain way. Right? Does that make sense?
Why would the post have a wallet? I mean, what is the post going to do with its wallet? It's like the post is like a small DAO.
The reason the post has a wallet is so that it can think about it like this. Right now, Facebook posts gather likes. Actually, they gather a wide range of sentiment now. So think of that. Think of the expression of sentiment as the very beginning of being able to gather promotional credit. And that promotional credit, you see, is that making sense?
Yeah, but one thing, so how do we know there will be a consensus on what's the smart contract model going to be for posts? Or there can just be many posts with many different types of smart contracts?
So again, I think probably what's going to happen is that different groups. So for example, there might be a social network group that builds on top of Rchain that provides one kind of view, and there might be another. So there might be a decentralized Facebook that builds on top of Rchain, and there might be a decentralized Twitter that builds on top of Rchain.
So it still has to be an application. So it still has to be, let's say, in quotes, centralized application built on that decentralized system.
I wouldn't necessarily say that it's centralized. I guess what I would say is that there's a community that provides a service. that community can be
But it cannot be completely independent in the sense that everyone is free to like post their photos and whatever, and anyone can aggregate them whatever way they prefer, just like if it was some sort of very large virtual storage, and anyone can store whatever they want and then aggregate that data whatever they want, however they want.
Actually, I would
arbitrary contract.
Possible.
As an advertiser, my contract can be, I'm going to pay you to look at to receive my stuff.
Yeah.
Now, there could be other requirements in the contract that it's really you, but it can be any contract for anybody for any purpose.
That's exactly right. So the nice thing is that the contracts define the means by which aggregators can aggregate the information, right? So if an aggregator likes the format or the
I see. Okay. So the contract has to decide if it wants to be compatible with certain structures, let's say.
Yeah, exactly.
I see.
So that's just one use case of many that we're looking at that we feel is enabled by the kind of architecture that we're providing.
I see.
Cool. Well, we have about 15 minutes left, and what I would like to do is to switch it over to Chris to provide a demo of the comms layer and how that's progressing.
Sure, thanks. I'm only going to take a few minutes, I think, and not show anything that the dev group hasn't seen before. If anybody's watched Community Debrief 38, Griff did a great demo of his key value store. What I'm going to do today is first share my screen, if I can find it. I'm going to demonstrate the key value store being distributed across 3 nodes. 3 is arbitrary, it fits on the screen nicely. Up here at the top, we have 3 windows that are just dumping the contents of the key value store. I don't have anything running, there's no contents. Each of the key value stores has a port on which it communicates with the other stores. So in this case, it's 33.33.3, and each has a port on which the user can communicate with it to set values, to get values, to make queries, interrogate it. So let's fire one up real quick. Yeah, it's not the fastest thing to go. And it's running. And I can set values on this guy, in this single key value store, and I'm going to go ahead and butcher Griff's demo a little bit. I want to set the key employee of Alice to be some data, 1, 2, 3 in this case. And I see it appear in my first key value store up at the top left. So far, so good. I can set other values. It's all very exciting. I can get the values using Griff's queries, and everything is hunky-dory. But what happens when I fire up a second node? Well, this is a little bit more complicated. The second node needs to know the location of at least one other node. So in this case, I'm going to set its home node to be that first node I fired up. The second node I'm firing up is going to listen on 33334, and it's going to have an HTTP port 8884. I'll go ahead and fire that up. Takes a little while. This is not really compiled. But now I have 2 key value stores, and they're communicating. If one gets mutated, the other one will observe it, and vice versa. I'd like to go over a little bit of what just happened. I even drew a picture so that maybe we can see what it is. These 3 things on the right are current network members. So right now there are 2. There could be 3 or 4 or 10, whatever. The protocol for a node joining the network is pretty simple. Right now, everything you'll notice is asynchronous. The new node comes in, issues a hello call, and doesn't wait around for any response. The hello call is processed by the home node. Any node can be a home node. There's nothing special about it. In order to join the network, this is more or less the process that it goes through. Introduces itself, hello, I'm me. That causes the home node to include this new node in its list of peers. Then the new node says, hey, tell me all the people you know about. all the other nodes you know about, and the home node will think about it for a second and send back a list of peers. This is not request response. Right? The new node doesn't wait around for the list of peers, but it does process it when it finally comes in. It's all asynchronous. Then it says, hey, catch me up on all your blocks. And the home node sends back a list of blocks. And then I'm done with the home node. I don't need them anymore. So I go ahead and disconnect from them. Don't have to disconnect there, but it makes a nice symmetry later on. Everybody has the right IDs and whatnot. Since I know all of the home node's peers, I just say hello to everybody, and I'm included in the network at that point. Eventually, I'll have pictures for the rest of the protocol. This is just the I'm starting the world up protocol. From that second node, just to prove that things work, I can get, come on, stop that. I can get all the employees that the second node knows about. And these should be all the employees from the first node. There's Alice, there's Bob. The key value store is a lot richer and more interesting than I'm going to make it appear here, just in the interest of time. I can start a third node, or I can even set values on the second node before I do this. But I can start a third node, and I can home it on the second node instead of the first node. It's got its own listen port, and it's got its own HTTP port. So when it starts up, they exchange a lot of talk, and it goes back and forth. And for debugging, I can set other employees. I'll set one on the second one, so you know I'm not cheating here. That was the second one. Everybody else gets the notification. So as you can see, this is a fully connected graph. The next thing I'm going to work on with this, there's a list of the first one's peers. It's got itself, and the second one I started, and the third one I started, and everybody looks about the same. There's the second one's peers, different order, same folks. The next thing I'm going to work on is not having fully connected be a necessary thing. So that, you know, you could have two peers connected to two other peers, connected to two other peers, connected to two other peers. As long as the thing's connected, everything should work fine. Any questions? I don't hear anything. I hope you can hear me.
No, this is awesome. Thank you so much, Chris. This looks beautiful. I think if you don't mind, I'll just expand on some of the capabilities here that maybe people haven't rocked.
Sure.
So first of all, one of the nice things about the key value store itself is, and this is what distinguishes us from, say, IPFS as a content delivery mechanism. The model that is employed here takes into account that the location of resources needs to also integrate the notion of query. You want to be able to query over locations and to query about content at locations. And unless you have that integrated, then things become a bit of a mess to manage. And the industry actually learned this lesson multiple times. One of the most recent ones in memory is the, for those people who know XML and XPath and XQuery. So XPath is kind of a path language within XML defined resources. And XQuery is a way of querying over those resources. And the two specs are kind of intertwined precisely because they didn't think about these things as recursively integrated. But with the key value store, we have them already recursively integrated because we learned that lesson from industry. So the model for the key value store provides us with a content delivery mechanism from the beginning. And then what Griff's demo doesn't provide is the integration of the Casper consensus. But we've built this all in a way that it is modular, so we can plug all these components together. So the communications layer, the node discovery layer, the propagation, and all of those features can be integrated with the virtual machine, and of course, most importantly, the Casper consensus protocol. So what you're seeing is the very beginning of our development process, and this is essentially without funding. You've been seeing these demos coming along steadily, from Kent's demo of the Rolang contracting language compiler to the Griff's key value store to Chris's comms layer. You've been seeing these come along essentially without funding. Now that Rchain's funding is much more secure, you're going to see our progress towards Mercury happen at a much more rapid pace, and we're particularly excited about that. So I again, Chris, thank you so much. I think this was a really, really remarkable demo, and it showed a lot of different features. Were there any, what's that?
Real quick.
Yeah, exactly. No, it was really well organized, and you conveyed a lot of information all at once. I hope people will take a careful look at this demo, because this was really, really spectacularly done. I really appreciate that.
Thank you.
Okay, so we got about 4 minutes left until the top of the hour where I have to take a call. Is there any burning question that people want to ask us before we jump off, or can we yield this 4 minutes back to the community?
Hey, I had a couple of questions on behalf of someone I was talking to about purchasing rocks, and I just wanted to, get you on record, Greg, on this question.
Sure.
So a number of those purchasing rocks, look at the percentages and the valuation as they would a security. And of course, rocks are not like that. In crypto space, there's the notion of coin market cap, which is a kind of an equivalent of valuation. And so those don't exactly apply. I'm not asking you to explain that, but I'm just trying to frame the mental model that many of these purchasers have. And so one of the concerns raised fairly recently was about potential dilution. So if someone purchases rocks and they believe that will buy so much compute power or be so much valuable as a percentage, and then the one of the following things happen: either the co-op chooses to raise more than $15 million, or another form of the question, chooses to sell its treasury rocks onto the market. Either of those actions essentially dilutes the relative power that purchaser would have to use the network. Can you address those? First of all, I want to say that the board has capped the sale at $15 million. And, I gave this purchaser my commitment to say, I won't pass the board resolution to raise that. And so, Greg, are you also of the same mind?
Yeah, I'm very much of the same mind. I mean, essentially, what we were raising was what we felt was comfortable to get us to Mercury. Where we had 100% confidence that with these kinds of resources we can get to Mercury, and that was and that's the intent. Once we get to Mercury, then the most important thing is that we get the rev out, right? That's the key point. So we transition from rock to rev, and at that point, it's in the co-op's interest that there is an ideal mix or distribution of rev throughout the community. That's what's in the co-op's interest. It's not in the co-op's interest at all to dilute or dump or anything like that. That defeats all of our goals and all of our purposes, right? I mean, certainly if we do that, then who's gonna want to run a node, right? I mean, it's just bad for business. And the real the real benefit to the business is all those applications that are running on top of the network, right? That's when people if they're thinking like traditional investors, that's when you begin to see the actual return on the investment. When you have a social network running on top of Rchain, or you have any of a number of other decentralized applications, whether it's a decentralized Uber or a decentralized GitHub, anything in that range is going to provide this enormous return on investment. And so it's not in the co-op's interest to do anything untoward with respect to the market. That would just be suicide. So,
right.
just from a common sense point of view, nobody wants to do that. And
Right.
so I think the most important thing,
members decide, and as a member, I wouldn't act against my own interest.
yeah, exactly, right. I mean, that's kind of the whole point here, is that the membership is guiding the co-op by giving direction to the board, and then the board implements the membership's will. And and this is all stated clearly in the bylaws. So yeah, I mean, I think that the most interesting thing is that um, how do you bootstrap trust? That's what's going on here, and people are having to grapple with this idea that, hey, here's a community that's really committed to a notion of a trustworthy and upstanding interaction. You know, the co-op is devoted to serving its members, and that's you know, it's something to wrap the head around.
Yeah, exactly. And I really appreciate your answers, Greg. And the interesting, we had a conversation earlier in the week around cooperatives. There's only one other cooperative blockchain project which we're aware of, which is Resonate. But I hope to see more in the future, because, you know, being accountable to the membership that uses the platform is quite a wonderful concept.
Absolutely. I mean, I can't emphasize this enough. I mean, the reality is that cryptocurrency has brought it right in our faces that financial instruments and governance go hand in hand. And so if we really want to talk about financial instruments that are connected to a governance that is fundamentally democratic, then the co-op model seems like one of the most natural ones to explore. Let's see, what time is it? It is 12:02. I got to jump off.
Greg, this is Danny. Real quick before you jump off, we had discussed
oh, yes,
a Rchain working group here in Seattle proper. And
yes.
I just wanted to make sure we take some next steps to getting that going. I don't know if I can create a Discord channel, or if there is an existing Discord channel we should use for that to generate some interest and figure out time slots. But I wanted to get that out there and get your additional thoughts on that very quickly.
Oh, thank you so much for reminding me, Danny. I'm sorry, too many things to keep track of. This is an important one. So yes, I wholeheartedly support your effort to get a Rchain working group going. I will create the Discord channel for people to coordinate. I really loved your idea of alternating times, sometime in West Seattle and sometime at Ada's. I think that's a great idea. Ada's is a great place to meet up. I also think it's, you know, I really want to encourage as many people as possible to start writing contracts in Rchain. And yeah, I mean, I think this is a great thing. And now that Kent has the multi-shot continuations working, we can have even more interesting contracts. So this is great.
Great. Yeah. And I think, you know, on the activist meeting earlier, I was on a conference call. I couldn't speak, but what I heard some commentary about was the fact that, you know, when we're talking to people outside the project, it would behoove us to have had some, quote, in the guts experience. And I think putting together a working group where we actually start using some of the tools and the technology that your mind has created, I think that will benefit people. And of course, I'm here in Seattle. I certainly think other Rchain working groups should start in other places. But since, you know, Greg, we are both in Seattle, and a lot of the people working on the project are here in Seattle, I think Seattle's a great place to start.
Oh, absolutely. I think you're spot on. So, you know, absolutely in support of this. And whoever wants to sort of get Rchain in their bones, sign up and engage. Yeah.
It's something we should definitely live stream.
Yeah.
Yeah. Seattle.
Yeah.
Hopefully we can do one in Tampa.
Yeah, absolutely.
That should be easy enough to do. I think we can manage that.
Also, if you want, you know, you've got a bevy of folks who can come and give presentations about Rchain. You know, like Joe Denman is now perfectly capable of giving presentations about Rolang. Kent obviously is good. Mike is good. I'm good. And hopefully there will be many others in the not too distant future. So, all right, I really have to jump off. Thank you, everybody. This is, as always, a lot of fun. Looking forward to the next one.